All right. Welcome to a special episode of Peach Pit. We are here in this, I guess, just wrapping up the off season of the FRC calendar year. Looking forward to kickoff in a few weeks, but we've again got a special episode here on, I believe, our topic or title wound up being how to keep your robot moving with our most of our normal Peach Pit crew and a special guest. While we hop in here, we'll go ahead and start with some introductions. I'm Kellen, one of our hosts. I'm a mentor with 1833 Bean, former mentor for 1746, among other teams. But I'll introduce our special guest, Matt Goldman from 1678. Matt, if you want to introduce yourself.
Hey, I'm Matt. I am a mechanical and strategy coach with 1678. Prior to 1678, I was with 2102 in San Diego for about 7 years. I've been with Citrus since the 2022 season. I already said it, but I work with our mechanical and strategy departments, and I occasionally pester our electrical kids as if I know better than them.
Hi, I'm Brian Carlson. I'm with Team 6829, Ignite Robotics. This year, going to be an electrical mentor because we're going to focus a little more there and hopefully get some more reliability in that area.
Go ahead, Thomas.
All right, Thomas, you're up next.
Thomas,
We practiced this.
we talked about this.
I thought I was going last.
Bedtime's at 10:30, not now.
I'm Thomas Priego. I'm a current math teacher at Chestatee High School, and I do some strategy things with Team 6829.
And I am David Allred, still clinging on from South Carolina in our newly formed 1st South Carolina district. Our first year as a district by ourselves. I am the CAD mentor and drive coach of Team 4451 out of Lawrence and Fountain Inn, South Carolina.
Awesome. Happy to have all of you. This is, I think, breaking any kind of streak on our episodes of having a very boilerplate intro, but we will include our normal disclaimer that any views or opinions shared on the show are solely that of the individual contributor and do not reflect the views of Peach Pit, any FRC team, Georgia First, South Carolina First, or any other affiliates and sponsors. Just to get that out of the way. But to hop into our content that we have on the docket for tonight, I think it's a critical topic that I think helps a lot of teams either develop or improve their current standards for how they wind up approaching build quality of the robots, or how they wind up trying to address those problems after the fact of if you've built what might end up being a subpar robot, of then trying to go back and fix issues. Is the general topic of how to keep your robot moving. This has a obvious impact. You only get so many matches throughout the year. I know it used to be the case for 1746 back when I first started. You'd go to 1, maybe 2 regional events, get less than 20 matches in your FRC season, and put the robot on a shelf until an off-season event came around. So the dollar per match in that era was just through the roof, and you really needed to make all those matches count. Obviously, at least here in Georgia and South Carolina, we're in a situation where we're playing district, and we result in us having a lot more matches. So fortunately, that dollar per match number has come down quite a bit. But that shouldn't mean that those matches aren't any more valuable when you're considering your team's goals of trying to make it to the next level for qualifying for district championships or world championships, or getting on a higher alliance or being an alliance captain. So this is a topic that really emphasizes or really focuses on the importance of your robot working every single match you're out there, showing to the other top teams at the event that your robot is trustworthy. You can put it out there. It'll do what you say it does. But I guess to get into it a little bit, and this is a topical conversation that kind of evolves as FRC evolves, and just because you'll have different electronics, different standards, different things that'll come through the years. But talking a little bit about what some of the common failures are in the current FRC era of things that are really common to see. We're excited again to have Matt here from 1678, who is renowned for their citrus service, I think is the name of the department. But they do a thorough job of working with their match and alliance partners to make sure everything's squared away before their match starts with them. I think we've had matches with teams in prior seasons with 1746 where we'd be at championships and a top team would come by before a match with them and say, hey, here's a checklist we'd like to run through you with you just to make sure your robot's going to work this match so we have a second set of eyes on making sure your robot's going to work as expected, or are you a team we can actually trust to run your own process? So it's always fun to compare notes in those situations to see either how different teams formulate their own lists, which is again a topic we'll get into here. But I guess Matt, we'll start with you. What are from your experience, what are some of the common failures or issues that teams should really be on the lookout for?
The easiest go-to is the CAN bus, right? It's a huge single point of failure on the robot, and it's a bunch of very small wires, which are very easy to mess up. So it's by far the easiest place to have a failure on the robot. It's either that or like the big power connections, your battery lugs, and your main breaker connections. I'd say those are probably the biggest pain points. And then into a mechanical world, obviously this year there was a ton of issues with every intake. I think there was a very much good grass is always greener on the other side thing where everyone with an under bumper intake was complaining about that front tube that bends in, and everyone with an over bumper intake was complaining about the thing always getting the crap smacked out of it. So anything that is going to be outside the frame perimeter is obviously going to be a big failure point. You have to be really careful about it.
Yeah, especially on the consistency mark of wanting to know the robot's going to work the same way. So I either have to build your robot to be modular enough that if something does break, that you can swap it out fast enough so it's going to work again the next match. But obviously, it's nice to guarantee that it's going to work the entire match as best you can. But some risk you just got to take.
What type of?
Sorry, go ahead.
Sorry. What type of items do you do to make sure your CAN bus is solid, and do you run more than one CAN bus?
We have 2 CAN loops on this robot, the 2024 robot, and it's basically one off the caniphore for the intake because it's going to get hit a lot, and then the caniphore has everything else on it. So there are 2 loops.
One is the Rio. The intake was just on the Rio one.
Yeah, the intake's on the Rio.
Gotcha.
It's the most likely to get hit, and we didn't want to take everything else done with it. Although I don't think that was ever actually an issue. I think that motor, of all the things that broke on the intake, I think the motor was always fine.
Gotcha.
The other stuff, it's always just really important to make sure you're strain relieving everything really, really well. So you want to make sure that none of your wires are ever under tension actively. And you want to make sure they're all really secured. Basically, our rule of thumb is like you shouldn't be able to move any of them. Every wire on the robot, you grab it and it's in its place and it's not going anywhere.
So there's.
I've got a robot right next to me here.
Okay, cool.
Hopefully the framing on this is all right, but you can see right here under the climber, we've got all of our wires for the encoders, and like they are tightly secured onto this on this module here.
They're just zip tied to the module.
They're just zip tied to the module.
Yeah, I think I've seen some teams even do like 3D printed little covers for those, just as exposed as they are to any possible intake coming in and contacting those. But the amount of wire, putting something out of your own frame perimeter is one thing, but also anticipating how teams might come into your frame perimeter is another.
Yeah, in 2022, we on our week 1, I won't call them out by name, but a team rammed an intake straight into our robot and ripped the whole CAN bus out. It was a pretty significant repair in the pit. And after that event, we ended up putting a little polycarb shield in the side of the robot just to keep them out.
Yeah. I mean, and that's something I feel like is consistent over every year. I distinctly remember, I think it was in 2019 when the cargo ship had the lip for
Oh.
that bumpers could fit under, but
Oh.
but the robot itself wouldn't. The amount of teams that would go in to place a hatch or some cargo and just take themselves out. And particularly now with the advent of Swerve, where you have motors right there typically sitting. Hopefully they're beneath the bumper, but they're on that bumper line, being aware of, hey, this might be something where it might contact field wise, not just robot.
Yeah, and I feel like it's still a challenge too with especially with most of the inverted motors on modules, on a lot of prevalent modules, as with the wiring connectors facing downwards. I guess we haven't seen too much outside of like wire bumps in 2023. I guess would have been the last like on-field kind of bump to go over, but is just. And I know some of the Kraken, I think, wiring adapters wind up causing a little bit more exposure for those wires facing down than some of the other wiring connection options. But just making sure. Sorry, go ahead.
The Krakens are actually fairly robust to it because the wiring largely comes out the side and then back up, so it's pretty easy to get that wrapped tightly away. I mean, the real trick is just make sure you're zip tying them down really well.
Yeah. Yeah, I guess I'm curious for the upcoming season or any other season that might involve any more on floor obstacles, is making sure that anything under your robot, especially I guess if it comes to a game piece that you might be driving over, outside of the very odds and ends, other robot mechanisms that may have fallen off that you might drive over, or hardware or swarf or whatever else. But just making sure that the underside of your robot is as protected as it can be from damage underneath as well.
What type of connectors do you use on your CAN bus?
As few as possible.
So
None.
None.
Previous years, everything is soldered. There's been we haven't done any of the little Molochs or JSTers, whatever they are. We this year are, at least right now, we're trying out some. Honestly, I wish I had the name of them off the top of my head. There's some of those little they're like little T-splice things where you sort of snap them down onto the wire, and there's a spade that grabs them. I'm sorry, I'm describing this poorly. I probably should have looked this up before I came on here. We're trying them out. We've got a robot coming together with them over yonder, and I'm sure we'll, it'll be playing defense on the main robot, and the main robot will have them for a while, and hopefully by the time we actually get to an event, we'll have proven out whether or not they're a good idea. So I don't want to endorse them strongly yet because we haven't actually driven with them yet, but we're trying a new thing.
But you're teeing into a loop.
Yeah, just teeing into a loop. So the idea is basically the CAN loop will have short spokes coming off of it. So big loop, short spokes.
Yeah, I think 359 Hawaiian Kids in the Jack in the Bot reveal thread where they made a clone of the 2910 robot. In there, I saw it looks like they run a blue green and a yellow green as dual CAN, but they use those vampire clips to sort of do short branches off. So one of the things that when you and I talked previously, and I think I saw in your strategy release for the 2024 season, talking about sort of like when you're looking at different robots and sort of grading some of their ranking, sort of like best practices and stuff, like latching, no connectors, latch connectors and stuff like that. So I want to sort of show some, let me present some of the common connectors you might see, and sort of have you talk about them and sort of normal, teams that can't solder, because soldering is a skill and sometimes it's easier to use some other connectors. What have you seen for some of these type of connectors, like the Molex SL, ferrules, lever nuts, power pole, and DuPont and stuff?
I don't have strong feelings about any specific type of connectors. It's more whether or not there is any kind of a mechanical fastening there. So the Molex SL latching connectors, obviously they're latching, which is fine. Those Andersons, Anderson sells little clips that can go into that sort of the little round hole there. Yep, those guys. Or hey, look, you've got right there. I was gonna say, or if you don't want to spend money, you can just put a zip tie on it. But what I'd look for is that there is a zip tie there. The DuPont connectors, those scare me. Although there are, I think, little 3D printed clips that I've seen some teams use to help hold those together. Wagos are, they can be totally fine. Again, it's a matter of making sure that they're really well secured down. So you want to make sure the levers can't pop up on their own, and you want to make sure that the connector itself isn't flopping around in the robot. Because if the connector's flopping around, it's going to put strain on the wires.
Yeah, which I think to go along with most of these connectors is I guess and this is something we've had experience with from my time on 1746, is the quality of which you can repeatedly make those connections for proper strip length, for proper crimping methodology. If you do wind up with some odd gauge of wire that the connector is not intended for again, making sure those things are done as much to specification for those connectors as possible. But if in all of those situations, to be doing proper tug testing just to make sure that you did actually connect it properly. I know we've had experience with the Anderson connectors that you didn't really get the resounding click that you get. I think there was a situation, I think this was early in 2019, which fortunately we found this before any actual matches started, but we wound up noticing, and there were, I think, had 6 mini sims on our drivetrain. So it wasn't the most noticeable thing, but we wound up feeling our drive motors after driving around for a while, and one of them was cold. They're like, well, let's do a little tracing there, and found one of those Anderson connectors just hadn't clicked in all the way, and we had been running on 5 motors the entire time for this drive practice. But yeah, making sure your quality standards are up to par. And something a line I used to like using with 1746 electronics team was, I want you to pretend like you're building a rocket for NASA, and this thing needs to work every single time. I want you to put that care and concern into this, as if to pretend like somebody's life depended on it. Just to put that level of care into what you're doing, instead of just going at it and saying, oh well, that looks good, and just passing by it without a second set of eyes carrying over it. So I guess a question for you, Matt, if you've got the insight for it, and I guess Brian and David for your teams as well, when you're going through wiring the robot initially, is there any standard by which you're proceeding? Is there somebody that's going through and wiring it, and if there's somebody else coming through and checking it right after them? Any standard of that sort that you guys are operating with?
So, I mean, the standard is the tug test, right? Every connection has to be tug tested, and you have to pull it harder than you think you're probably going to have to. And that's the top tier test. Like everything else is weird, finicky little details. Typically speaking, I mean, the way we operate is we do it as best we can, as fast as we can, and then we just test, right? So we drive a lot on field at our facility here. And typically speaking, that's how we shake out issues electrically. The first couple weeks we have the robot, it's dying all the time, and we're just slowly identify a failure mode, get it fixed, identify a failure mode, get it fixed, until eventually week 1 rolls around and we try not to die in the field.
Yeah, this was a point I was going to make on your comment for trying out the new connectors. Is as often as you can, try things out and test them and fiddle around with them before the season starts, for seeing if they're actually going to work, or if they meet your quality standard to actually put on the actual robot, instead of really experimenting on the robot in actual qualification matches, and then trying to recover after something goes wrong. But yeah,
you made a point about how expensive it is to be on the field, and we're still in the regional system, so every match is still very expensive for us. And even in a district, it's not like a match is cheap, right? Like a match is still what, $200?
Yeah, I haven't crunched it recently, but yeah, still pricey.
Yeah. So you really want to know what your robot's going to do by the time you play your first official match. You don't want to find out on the field.
Mm-hmm.
So,
The practice
yeah.
match, isn't it?
So I will share something here, and I already warned my team I was going to share this. So this was a top-down view of our bot last year, and one of the reasons why we're putting a lot more focus on it this year as a team is this was a result of not focusing enough attention on electrical intentionally, and at the last minute trying to get things done right. So it's not nice and tidy, right? So there could be something will come in there. Now, granted, this isn't way down low, so it's unlikely, but it still could happen. Could yank wires, but even though we used the DuPont connectors, we had the safety clips, and we did use the pins on Anderson's. But it's this kind of thing we're going forward this year. We want to sort of standardize on connectors. So we're going to be looking Anderson power pole for power, and then we're going to use the Molex SL connectors. And part of that is process. So student does the crimp, another student does a check, and then me as a mentor overseeing, right? And double, because with some of those things, as you pointed out, Kellen, with the power pole, it could be just a little bit off, right? And so having a process to do that. So even if you're in a smaller team, have somebody else check. So that's kind of where we're going this year. We've noticed in the past that as season has gone on, we have struggled a little bit, and part of that has been trying to find wiring issues where we don't show up right away, but they eventually through the course of the season have problems. So Matt, one of the things that you had mentioned previously that I've seen is you've talked about doing a drop test a little bit. Can you explain that process and how you use that and when you do that?
Yeah, so drop test is just kind of a way to simulate some of the like a hard impact you might see on the field. So, and I'm sure everyone who's done this for a while has had an experience of the robot hits something hard and then stops because the CAN bus died or something else died. So drop test is a real easy test. You just pick up the side of the robot, maybe 6 inches, and then drop it, let it go, hit the ground hard, and you just watch the CAN bus indicator lights on your motors or controllers or whatever it is, whatever it has an indicator light. And we typically do once per side. And that usually that'll help dial in like, okay, on this side we had a CAN bus failure, and on this side we had a CAN bus failure, but these two we didn't. So it's probably this corner of the robot right here. So let's look at that Swerve module.
Mm-hmm.
Is
Yeah,
the-
we've had fun ones at competitions of trying to mimic any kind of test of like, oh, in that prior match we had a heavy hit that resulted in us dropping comms. So you get back to the pit and power the robot on and enable it, and kick it or find another set of bumpers and start whacking your own robot. For the amount of times I've seen people beating up their own robot trying to get it to mimic what happened on the actual fields. It's funny
I love
to watch.
walking by a pit and seeing like 6 people in a circle around the robot kicking it. It's
Yeah.
my favorite thing to spot in a pit.
Yeah.
So the drop test, it creates way higher G forces than you can kick a robot with. But also keep in mind it's putting load in a different direction. Normally robot to robot action is sideways. A drop test is top down. So it's not a perfect simulation, but it is pretty good. We on our one of our picks at champs this year, we had actually spotted when doing pit inspections that they had what looked like a kind of a shaky CAN bus connection, and then picked him and they were like, our CAN bus is having problems. So we drop tested it and it was like, oh, there it is.
Is there a reason to do the drop test outside of doing something similar to being like a cinder block wall test where you're instead of dropping it, you're just driving the robot full force into something that won't break? Or is that just...
You have a cinder block wall available. Yeah, do it. 330 swore by the brick wall test, and who am I to speak against 330, right?
Yeah, nobody.
Yeah.
So just out of curiosity on your CAN bus, how do you do maintenance or replacements if you had to like replace a Swerve module? Would you cut the CAN bus, solder one back on?
We typically cut and solder. And after enough replacements, that can start to be an issue where you have sort of a bunch of solder joints in a line.
Right.
So this is, I feel like everyone has their own personal theory on how you make a robot not die. So I pay a lot of attention to how many connection points are there between point A and point B. So if you have like a Molex connector or an Anderson or something like that, you've got a crimp and then you have a contact and then you have a crimp. So there's 3 connection points there.
Mhm.
What I like about a solder joint is that it's one connection point. It's just wire to wire. And like a Wago is 2. So the
Okay.
fewer connection points, the better. And when you start to get a wire that's been repaired a bunch of times, if you've got 5 solder joints there, that's certainly not going to give you the benefit of soldering. In fact, we actually had to no-show a match at Jazzy Champs this year because we had a wire going to our shooter that had been repaired too many times and it had a solder joint right on a bend line, right where it used to bend, right where it bends into the shooter.
Okay.
So we're not immune to it. It happens.
Good.
Sorry, 6800.
Yeah, I think also a fan of the soldering, and again, as you pointed out, the fewer connections, the better. But I do like it like in a hot fix, and again, I think this is a side effect of being in the district system, is generally, at least historically, a lot of PCH events have been. You'll wind up with several events in that 25 to 30 team ballpark, which results in a really quick match turnaround time. So you don't get the benefit of running through a full pre-match checklist, or if something goes wrong your prior match, you're looking for a fast fix. So I like, in my mind, I think there's the benefit of the connector type of being able to kind of bypass certain mechanisms to say like, all right, let's isolate that, or for troubleshooting of is that really where the issue is, for being able to plug and unplug, for being able to isolate as best you can. Obviously, there are different ways of going about that for either looking, trying to flash different motor controllers and saying where an issue might be at. But if you are soldering everywhere in a fast-paced environment, that's where I like the ability for taking a Wago or something of that sort and chopping into and being able to put in what might just be a temporary connector, but something that's going to be fast enough that you don't have to sit there and solder in something new in order to potentially be ready or not ready for your next match.
And we'll keep stuff like Wagos on hand just in case we need to do a really quick fix like that. It's not our preferred choice, but if it's like we are field side during a field timeout, we're loading in 3 minutes. Like, yeah, we'll just toss a Wago on there. It's faster.
Yeah.
Then what type of connections do you do for power runs to motors?
So since we moved to Krakens last year, they all have those ring terminals, which means we can just do a continuous line the whole way through, no connectors.
Okay, so it's the continuous line right to the Kraken.
And if you need to replace the motor, you undo it at the motor end and not in a wire. Yeah.
Gotcha. So 0 connectors.
0 connectors, which is the best number of connectors.
That is the best number. Remember, students, the best number is 0. 0 failures. The way I describe this to my students is wiring has to be perfect. There is no second place.
I agree with you, David. But I think, as Matt said, whenever it is the time for wiring to happen, generally it's like, all right, this needs to happen like this because we got the rest of the robot to put on top of this thing. That generally, when you are doing the wiring for a robot, it's like, all right, this needs to happen as fast as we can, because this isn't really a huge emphasis of the design of the robot. Obviously, the designs happen, the manufacturing's happen. Now we really need to test the programming, and the electronics and wiring are just this pesky in between that I think often get the short end of the stick for not getting the emphasis it deserves, to making sure you're building a quality robot that's going to work every time. But.
Yeah, I mean, we're guilty of that just as much as anyone else, of being like, the parts are made. What do you mean it's not operating yet, right? Yeah, like we push our electrical kids pretty hard to wire everything up really fast. They're good at it. We solve every problem exactly the same way, which is we train the kids relentlessly all off season. We build as many robots as possible so that they've wired as many robots as possible by the time they hit the season. So like an experienced electrical kid has wired up 20 robots by the time they're done here, which helps get it done a lot faster during build season. Obviously, that's not like, not everyone can do that. And I understand I'm speaking from a serious point of privilege there. But that's typically how we solve problems.
But to that point, I guess if you are a student on an electronics team out there, don't wait for that window to happen to start thinking about how you're going to wire up your robot. Put as much
plan it ahead of
effort
time.
as you can into figuring out, all right, let's get a count of all the necessary components we're going to need. Start doing routing pathings to check with your mechanical team to figure out where can we run those wires. Especially should you need to drill through something later in the season to know that it doesn't have wires running through it. But having a plan in place to account for being able to get that job done as quickly as possible, but at a really high standard as well.
Right. So yes, your team has the ability to go through several robots, and that's there's some benefits of where your program's at, right? And not every program is there, but even on Ignite, when we first started it, we sort of have the philosophy of we don't try things in the season. We execute in season and try to train off season. So even though we may not have a vast number of students, or we may not have a vast number of robots, we're just working on the one robot. We still try to focus somebody, and this year we're focusing on electrical, is training some students to be ready for that, right? So even if you're going to just say we're going to use this connector or that connector, or whatever your standards are going to be, is making sure you do it right and then you secure it so that way it can't come unconnected, right?
So I think a lot of the trick to getting it done quickly and sort of riding that balance between do it well, but also get it done fast enough that the software kids can get some time on it. It really comes into pre-planning stuff as much as you can. I wish I'd gotten pictures of it, but we always have a whiteboard where you've got like basically what's every electrical device in the robot, what wires does it need, and then like a guesstimate on how long that wire is, and then you add like 20%, right? We're not going to go through CAD and be like, this exact wire route is 23.418 inches, but like we can say, it's probably 2 feet, so we'll cut 3 feet of wire for this one, and we'll lay it in as soon as we can, and then cut it down. And that really helps to speed things along.
Mm-hmm.
Y'all typically wire your drive before you start putting the scoring section on, and then layer in the scoring section over top of that?
Basically everything we can do as fast as possible we do. So the alpha drivetrain is already together. It's last year's alpha, that's done.
Mhm.
The beta robot drivetrain will probably start coming together day 3 build season.
Mhm.
Assuming we don't have to do anything weird with the drivetrain, assuming we can do our normal 26 by 26 drivetrain, that'll start coming together as soon as we can get parts made for it. And once we've decided that that robot is viable, then comp will start coming together probably week 2, and the drivetrain will come together, as soon as possible. Basically, as soon as the beta robot is complete, the comp drivetrain will start coming together.
Right. And so the interesting thing there is they don't decide on drivetrain. Every year they're doing a 26 by 26, right? And so there's some challenges with that building smaller, right? And we might go a little larger, but if you sort of do that year after year, it becomes something that you can rinse and repeat. And it takes one less thing you have to do a lot of discussion and debate about to figure out what you're going to do. And you can spend that time on something else.
And that's
Definitely.
one of the
Yeah.
That's one of the nice
Right.
things about having and the movement towards COTS Swerve and various COTS components is teams don't necessarily have to build, or gone are the days where you have to build your custom West Coast drive every single year. It's just build a box, put modules in corners of said box, and move on with your day. So you're not, unless you're a team that has swapped the type of Swerve modules you used for 3 straight years, you're generally able to move and progress as you're going.
Right. Now, although there are a lot of swerves, especially rookie teams probably won't be at Swerve. They'll be at
Alexa,
the
turn on
tank drive that's for the KOP, or they'll be doing West Coast Drive, because Swerve does cost a good amount of money to buy. And so even in that model, you still just save your decisions and time for other things, because the drivetrain won't win you the match, but it can lose you the match.
And like if you're a rookie team and you don't have the money for Swerve, the AM14U has an even bigger benefit in all this, which is that all the parts are already made. Like you don't even have to wait for the step where you cut a bunch of tubes to length and all that. You just pull it out of the box and put it together. And if you, like before the season, just practice that one, pull it out of the box, put it all together, take it apart again, be ready to go. Right? You can build one of those things in an afternoon if you're really on top of it.
But in those cases, right, that's the Kitbot has Spark Max controllers, so you've got wires going to the sim motors and then wires going to the power distribution panel. So basically, you have to have some connectors there. So basically, you just want to have one on each side, and that's all you can really do. I'm going to be working with the rookie team this coming year, and hopefully we're going to probably use the a Wago style power distribution for those, because they're simple. I don't trust new people with crimps.
That's
I got you to pull.
really smart. Yeah.
I'm sorry.
I don't trust me with crimps.
I don't trust crimps. I'm sorry.
So
the Andersons are nice and pretty and shiny, but you got to have a good person that can crimp.
yeah, I was visiting the CTRA shop a couple of weeks ago when I was back where I grew up. They happened to be in the area, and I was talking to them, and everything they did inside was all Anderson power pole, because you didn't have crimps. So it's just it's easier connector to do if you don't have the ability to have the double check of doing crimps. So yeah. Out of curiosity, when you're coming in between matches and you're starting to looking at the robot, what kinds of things are you looking at, and what's that sort of process like? I know we have pit checklists, everybody has pit checklist, right? So what kind of things do you do for the control system between matches?
Well, control the whole thing, actually.
Well, true, but I just want to make sure all those things the motors are moving, kind of thing, right?
Yeah. So we have we'll always have a standard systems check that we do, which is just going to be a basic routine of make sure everything moves and actuates the way it was supposed to. So this year it was intake and then up to the amp elevator, intake, amp. We do everything 3 times, and then we do intake, shoot, intake, shoot, intake, shoot. And then you have a kid, and then actuate the climber. And then we'd have a kid sit, not sit under the robot, but sort of like carts up here, kid poking his head down here and looking at the modules and making sure, and the driver goes forward, backward, left, right, spin. And he calls out good, 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 good as those checks go through. So we have a standard like systems check, but there's also a pit inspection checklist, with the robot off. Control system specific stuff, it's largely checking wires, making sure that no wires are in any little pinch points, no zip ties have broken, all the connectors are tight and not moving. Going through and pull testing wires if need be, making sure that there's no visible copper on any wires anywhere. I know that in 2022, we had a wire that was running like just under the ball path, and it was like over the course of like hundreds and hundreds and hundreds of cargo going through that, the wire was starting to abrade. And it was at our near the end of our week 1 event, you'd start to be able to see a little bit of copper on a wire just from cargo rubbing on it over and over again.
Wow.
Yeah.
And as far as your pit crew, do you sort of, when they're looking at, do you have like certain students looking at certain subsystems, or are they looking at this? Everybody's looking at system in general. Or do you have a static or more dynamic pit crew? Sort of that kind of
So
intangibles.
for the students, we will typically have a student on pit mechanical, a pit electrical, and a pit software. So we'll have 3 dedicated pit students in there. And then we also have usually 2 pit coaches. So typically those are Peyton and Devin. Peyton does preventative maintenance, Devin does corrective maintenance. They both do both, but sort of have their specialties.
So Peyton and Devin, are those students or mentors? I'm not sure.
Those are coaches.
Coaches are.
So typically speaking, in the pit, there will be 2 coaches and then 3 or maybe more students. So we'll have the students do have specialties, but it's not like an intake student and a drivetrain student or anything. It's mechanical, electrical, software.
And so, and those stay for the most part static with left,
Yeah.
maybe a break here and there kind of thing.
Yeah, like we'll have, maybe 2 students who are assigned pit mechanical so that someone can go on a break. That we'll have a backup, something like that. The only time when we'll like actively sub out students through the season is if someone can't make it to an event, obviously for some reason, then we'll bring someone else. But we really try to keep the kids who are in the pit all year, because typically speaking, they are our most experienced kids. They're the ones that are gonna keep their heads in the game while things are going wrong. They're the ones who are gonna fix problems quickly, the ones who have seen it break 1,000 times before.
What do you do with your technician position? Do they work in the pit at all, or they just work with the drive team?
That is typically, I guess the past couple seasons, our technician has been our hardware design lead. So that's basically the lead mechanical student or the pit mechanical. kid.
Okay, so they do kind of go back to the pit then.
Yeah, it's nice to have that person travel with, or at least have the drive team come back and say, "Hey, these are the things we noticed in that match that you might want to be checking out." To pass those,
Yeah, it's
have
important to
somebody
have.
directly pass those notes to the pit.
Yeah, on the drive team, you want a mechanical kid, an experienced mechanical kid, and an experienced software kid. So that way, when stuff goes wrong, they've got a good view of it, and they can see like, oh, I recognize that failure. I've seen the intake droop on that side before, and I know what this is, or whatever.
That's what we do as well. Our technician is like our 4th member of the pit crew, and it usually is a software person in our case. But we could, I guess, do a mechanical.
Yeah.
I mean, our technician was mechanical because our driver was our software lead.
Gotcha.
And if our driver had been the mechanical lead, we probably would have had an experienced software kid and the technicianship. So
Yeah, I recommend that strategy too. It's a good continuity between the drive team and the pit.
Right. One of the things that we're going to be doing this year is when the robot's out in queue and get ready to go and match, there's not a lot for the pit team to do, is to go watch that match so that they can see operation. And so when they come back, it makes it a little easier of a conversation between drive team and pit, because they've already seen that hard hit that may not have been impacting functionality, but for them may cause them concern.
yeah, we keep a TV in the pit that whenever we can has an event stream on it. So we'll, if the robot's not in the pit, the kids are usually watching the stream. Really, what we want them doing if the robot's not there is cleaning the pit, and putting away all the tools they brought out last time the robot was broken.
Yeah.
Mm-hmm.
Or in the case of this year, repairing the intake that they just took off the robot, because that happened basically every match.
Okay. What type of mechanical? I mean, since you're mechanical, right? What type of mechanical
I'm
failure
mechanical.
points do you see, or mechanical maintenance that you do on the robot?
So the biggest failure point this year, beyond anything else, was the intake. We had an over bumper intake, which meant that it was getting hit a lot. When we first built an over bumper intake and we were like, okay, we're going to do this, we said, we're going to make this thing indestructible. It's going to be thick aluminum and it's just going to be a tank. And that made it, it didn't survive contact with the first event, right? Like there's there's nothing we could have put on that robot that would survive running into the truss at full speed.
Right.
And it's so that didn't work. And the problem there is that the way that this intake is constructed, we knew it was going to have to be replaceable, but we have there's a shoulder. It's right here. All right, so there's right here is a shoulder joint piece. So this is actually 7075 aluminum. It's very strong. And then this is the rest of the intake, which is bolted on there with these 3 bolts. So it's very easy to take off and put back on. And we knew that it was going to get the living daylights beat out of it. So it had to be easy to replace. But the first rev of this was also 5/16 aluminum. And the problem is that was so rigid that every time it took a hit, rather than this piece bending, this piece would bend. And this piece is terrible to replace. This is like a 45-minute job to replace this.
Yeah,
So
designing in the breakpoint that's easy instead of
exactly. So we solve this the brute force way, which is that we have 3 of these intakes. There's typically 1 on the robot, 1 being actively repaired in the pit, and then a 3rd one that's ready to go on when the robot gets back and is broken.
Gotcha.
Yeah, so
guess
that was
another-
our biggest mechanical failure point. Other stuff we're looking for, there's a lot of real basics. I mean, loose nuts and bolts, rivets that are getting loose or wiggling out. If there's an elevator, then we want to check for worn Dyneema cord belts, anything like that. Anything rubbing against sharp spots, cracks, tears, bends, missing hardware. Anything that moves that feels different than it usually does, like if it's usually got some friction to it and now it's moving really freely, something changed, that's probably not good. Same with vice versa. If you see a bolt that has a gap under the head, that's probably wrong. If you see a standoff that's able to spin suddenly, probably wrong. Stuff like that. One trick that that Peyton, our preventative maintenance guy, does is he has a flashlight, a narrow beam flashlight, because it forces you to focus on one spot of the robot at a time. If you do use a phone, which has a really diffuse light, then you'll just be sort of seeing everything. But if you have a narrow beam, it sort of focuses your attention in and you can sort of methodically go through the whole thing.
So do the students then do a field test with the power off, moving things around to see if it feels different to them?
Yeah.
Interesting.
Wiggle the intake, move the elevator, stuff like that.
So when you come, typically, every robot's sort of unique, but generally speaking, when you get back from a competition, is there a certain pre-planned maintenance that you expect to be doing to avoid something failing, right? You just know that these things are an area that are prone to failure or wear.
It's not like we have one consistent like check post-match or post-event checklist that we do. We usually build something we call the fail faster database, which is just basically a list of everything that went wrong during the event, and it's kind of a DFMEA where it's like where there's like, here's what went wrong, here's who's responsible for fixing it, here's the current status of it, and sort of we do that as a way to track those issues. We were not great about it last year. We were really good about it in 2023. For the most part, honestly, this is one of those places where we probably should have a really formal process and we don't. On the drive home from the event, we will have Mike or some other mechanical coach basically just chat with a student and list off everything that went wrong. And a kid sits there typing it up in Slack and sends it, and we'll have a big Slack post somewhere in Slack, just sort of detailing out all of the various broken things or designs that needed to be tweaked or whatever else there is.
Those would be conversations we'd have of what went right, what went wrong, and what do we need to do better next time.
With the
The
intake.
trick is acting on that. What do we need to do better?
Yes.
Closing the loop is the hard part.
Well, yeah, we'd always have problems because we'd do it and I think do better. Like the immediate next event we'd go to, great, you're fine. But like talking about next year and like having people go back and review the notes from the prior year of hey, we made these mistakes. Let's not make them again.
Yeah.
Is definitely learning from those lessons instead of tripping
So-
over it.
It's really frustrating doing
Same
one of
rock.
those debrief meetings and then like looking at the list and being like, all of this stuff looks familiar. Like I feel like we said exactly the same things last year and we learned nothing. I hate
So
that
the-
feeling.
The one thing I want to point out, and so, Matt's made this comment where on the way home, we're starting to do a debrief, right? Kellen, in 2023, you were already realizing there are some changes you wanted to make at competition after the Gwinnett competition in week 3. And those started working on basically the very next day, right? And I know, in talking with Chris Wilson from 1771 in 2022, their student was already working on a V2 of their shooter during the competition. I think the takeaway from all 3 of those is save time when you can, and don't wait 3 or 4 days after the event to do stuff.
Yeah. A lot of times you have to act fast. In this particular instance, we had them like I think we were doing 3-5 for our competitions.
Mhm.
So our first competition was a Saturday, Sunday. So we had literally the 7 or 8 days between our events, and we realized at our first event that our robot was terrible. So to realize that first day of this is not the robot that's going to accomplish our goals. And to be able to have our mechanical lead in a pit position that wasn't as crucial, to be able to pull him aside and say, hey, we need you to start looking at what else is out there and what we can pull off in a week, while everybody else on this team works to milk the most district points we can possibly get out of this particular event. But you need to be sitting off to the side with a mentor or two and just focusing on this entirely separate problem than this particular event. But on our topic of keeping the robot moving, if you're rebuilding your robot in a week, you're bound to stumble across some problems. So I think it was the week later at our next event, we wound up trying a PDP or a PDH because we had not properly seated the 4-gauge wire back into it.
Yeah, you melted it at the connector, didn't you?
Yeah, nasty smells.
Right,
Would not
but
recommend.
but that bot did win PCH and make it to Einstein, right?
Yeah, and we wound up with some nasty electrical issues on Einstein because we very much took the the high tide strategy of mash into everybody you possibly can, and our chassis was suffering greatly as a result. That I think it was between a couple of our Einstein matches where we noticed one of our steel plates on the belly pan, which we had foolishly riveted in. No, sorry, this was a polycarb plate that had a steel plate zip tied to it. So the amount of hits this polycarb plate was taking, it wore through the rivets that was holding it on. And that was dragging on the floor and pinching wires. And luckily we caught it between matches before it was an issue. But even I think while we were in our division playoffs, we were having a fluttering CAN network that luckily it was an issue that we would drop for a second or two and get connectivity right back instead of being down for a radio loss for 30 seconds and then coming back. But fortunately, we had Walton had graciously sent over a couple mentors for helping us troubleshoot those issues. And we're going through all of our connectors we had in line to figure out exactly where the issue was. But luckily, had found it and got ourselves back out. Again, luckily, we never dropped a complete match, but it was very frustrating to be driving and then stopping and being in your teammate's way for a second or two before you could continue going.
Yeah, actually, in 2023, we ended up. What was how did these events go? It was we had the comp robot and a practice robot, and the practice robot's wiring was just abysmal. So maybe 5 days before an event, Nick, who was our electrical coach at the time, he passed away last year, but he basically said, okay, this is bad. So he tore every wire out of the practice robot. And he basically walked them through. We're going to lay out everything. We're going to measure every wire length. We're going to be really, really detail oriented about every single part of this. rewired the whole practice robot, and it was beautiful. The single best wired robot I've ever gotten to have my hands on. I don't want to take credit for it because I wasn't part of it.
I was
Purely the
nearby when it
professional-
happened. Yeah.
I saw it.
What?
And when it came to actually go to the event, we were looking at the comp robot and the practice robot, and we're like, the practice robot's 1,000 times nicer than the comp right now, and that's what we took to the to our first competition was the practice robot instead, because it was just in such better electrical shape.
What type of preventative maintenance do you do on Swerve modules in the brand new world of everybody swerving?
So the one thing that we do that I think a lot of teams don't do is we actually torque paint all the bolts. So if you don't know, torque paint is basically just like a.
So you're just creating a line off the bolt just to make sure it's still.
Glad I moved this thing over next to me. Yeah, so you can see you got all these little green lines on all the bolts. I'm sure these have all been disassembled so many times since the event, but basically just a little line of paint on every bolt, and that way you can see if any of the bolts move. So
Yeah, so
for the
you're just doing
inspection,
something like that. So yeah, the
Yeah,
bolt
there you go.
twists it all, that you then have misaligned lines and you know something changed.
Yeah.
Neat.
So we'll torque paint all of them before an event, and then that way when you're going through inspection, you just get the flashlight, look through each individual bolt on the module, and if any of them have moved, then you know you need to clamp them down, and you can catch failures way before they cause issues doing that.
Wow.
Obviously, check your tread.
Right.
Everyone knows that. Spin the modules by hand. Make sure they don't feel crunchy or stiff or anything like that. You know, spin multiples of them so you can go like, actually, this one feels really different than this one. Having that comparison point is really important. Other preventative maintenance. Nothing else coming to my head on preventative maintenance.
Anything about the gears themselves in the module? You just replace them every year? Or they replace them every competition?
We haven't had a lot of gear failures
on yours,
on
right?
modules.
Yeah, it's just keeping them lubricated.
Yeah, keep them lubricated. You have to make sure you get the right belts. So there are, it's really easy to get like cheap Chinese knockoff belts for the slew bearing on the SDS modules. The genuine Gates belts are going to last way longer. We got a batch of the cheap belts a couple months ago, and we were basically only getting about an hour of drive between failures. Yeah. It was really frustrating. Just basically like every drive practice would end because we'd break a belt in a module and be like, all right, well, that's it.
Yeah.
I don't want to deal with this right now. So put the robot on the table. Someone will fix it tomorrow.
Yeah. So David, I know 1771 had new belts in 2024, and they broke one at Worlds. So they're now going to basically swap belts probably before DCMP or Worlds going forward. You do that once, and you're going to change your behavior from now on, right?
Well, it's not just that that one team. It's everybody.
Exactly.
There's so much swerving out there.
Yeah.
We had a module that wasn't properly greased, and we burned up a steering gear, and it locked up a district champs. Burn out a turning motor. Because
I don't think we've failed a gear yet. But we're actually moving to the West Coast X2 modules this next year. Those are all geared, so no more belt failures at least. I'll say I have a preliminary concern about the height of the slew turning gear. It's really, really short, so it's going to be a thing we keep an eye on, obviously. But at the same time, I trust that RC knows what he's doing, and 1323 is going to be running them, so they wouldn't put something out there if it wasn't going to work. But
yes,
we're making that swap.
Yeah. I guess another question, something similar to what we've covered for, I guess, running your own team through any pre-match checklist or preventative efforts. When you are doing citrus service, are you running teams? I don't know if you're running teams through, or when you're sending people out, are they generally keeping their eyes on particular things? What are the biggest red flags, I guess, you're looking for on that citrus service effort?
So citrus service is a reactive effort. People come to us looking for help.
Mhm.
So we're not typically, citrus service doesn't go into people's pits looking for issues to fix.
Gotcha.
We have an alliance readiness group that goes and checks alliance partners for matches, which is a
Gotcha.
separate group of kids.
No,
But typically speaking, I mean, they're going to check for everything we just talked about. Oh, hot glued connectors, Ethernet, little DuPont connectors on the Robo Rio. That's the thing we look for. Yeah,
So-
not a lot we haven't already talked about. Oh, one other thing to note is that the Robo Rio has all those little pins on top, the digital IOs and analog IOs. We typically electrical tape over any of them that aren't being used just to keep any swarf out of it.
Yeah,
Do
I've
you-
seen some fun pictures of Rios taken apart just for the amount of nasty
Oh,
stuff
yeah.
that gets in there.
So do you have any, other than the RSL and CAN, do you have anything else plugging into those DIOs, or are you generally all CAN?
We this past year had a couple of beam breaks that were plugged into those. Right at the right after the intake, there's a little indexer that has 2 beam breaks which go into the DIOs.
Yeah.
And they are hot glued in place.
So we've had beam break issues. Well, we've had beam break issues mostly because being a community team and going outside, our beam breaks don't work because of all the direct sunlight, right? But we ordered some of the CAN range sensors from CTRE, and I'm hoping that we can not have anything plugged into the Rio. Because I don't, trying to strain relief that is sort of difficult. As
Yeah.
far as strain relief goes, I do want to mention to people 2056 OP Robotics in their reveal in their CAD, and in that thread, you'll see they have all their components are mounted to 3D printed brackets that have built-in strain relief. So you have strain relief to the wire like within an inch or two from the connection. And so that way, it's, it's built in. So you slide the zip tie through the 3D print, and it ties down. And so you can look at them. They did publish the STLs for those.
So we built a clone of that robot. Right there. And we saw the same thing, really loved it, and we're currently in the process of designing little 3D printed saddles, what we're calling them saddles, for all of the major electrical components
so
that
how
have strain relief points.
are the saddles just double sticky tape down, or and then you?
We're designing in bolt holes, but knowing us, there's
Oh.
a 70% chance that it's going to end up BH bead. Yeah.
We're going bolt/rivet. We've had some issues with the adhesive zip tie anchors you can put all over the place. We've had issues with them sticking to powder coating. And so we don't want these to move. So we'll do some sort of mechanical fastener.
Oh, okay, interesting.
We're designing to mechanically fasten everything. That's optimistic. I know we're going to be lazy in VHB at all anyways.
Yeah.
But it's December. We can pretend we're going to turn over a new page.
Yeah. I guess on our topic here of standards, are there any, published standards for electrical? I think electrical is like the easiest thing to point at because it's largely wash, rinse, and repeat from year to year, for not having a ton of major component changeover. Are there any good design resources or guides that you'd point your finger at of this is a gold standard for the community, or at least a really good starting standard for you to start with, to then if you want to improve off of it? But any, thing of that sort. I know there's like and I think 900 had done a battery guide several years ago
Battery
that
guide is
wound up
great.
becoming a standard. Anything of that sort anybody has that they'd make recommendations for?
I don't know if 1538 has an electrical guide, but I'll bet they do, and I'll bet it's excellent.
Yeah, I think they hosted. I don't know if they hosted an event that I think had like very limited tickets to it. But I remember that being a hot topic of like, can you please focus on this and share your notes? But yeah, those are some of the prettiest pictures I've seen of FRC wiring winds up being 1538. As again as a gold standard. But I think like WPI Lib has some guides up on their site for either hardware basics and then a few things on there for wiring best practices, CAN wiring basics, robot battery basics, things of that sort that wind up being good starting blocks for teams to start working with. And they look fairly up to date, at least for having like, I think they make mention of grasshopper nuts and things like that for batteries for good use cases there.
Yeah, grasshopper nuts, or even if you just grab some Nordlocks, those are hugely beneficial for the battery lugs and the main breaker lugs. You know, some of the biggest single point of failures you can have on a robot.
Yep.
Yeah.
I always get a chuckle out of getting a new battery and having the little the lock washer that'll come with the cute little nut and bolt that come with it. It's like, all right, there's the garbage.
Yep, nope.
It's like, yeah, if you're brand new to FRC and you're opening up an FRC or a new battery, get rid of those things as fast as you can. Make sure you're using nylon locking components. I think I pointed out to Brian as he was kind of putting their standards in place for like the main breaker. I think has the star lock nut with it. I'd recommend changing that out if you can to then using a nylon lock nut instead of depending on the star grip lock nut that comes with the breaker more often.
Looking at every year or two replacing the breaker, because that is a breaker, not a switch, and we use it as a switch. And there are cycle counts where it could become easier to trip if you get hit. So now another thing about the breaker with the nuts and the battery, those things are kind of devilish in a way because they look good and you think you're trying to track down a wiring problem in your system when it really isn't. It's really the connector at the battery.
That's
Yeah,
a really good point.
On the battery front, it's also important to have testing routines in place. I'm trying to recall if this was covered. I think I'm trying to remember if there was a video put out recently of good standards to have for those. Because testing is one thing, testing how often is another thing. But again, on these are the things that are happening most often is you're going to use a different battery a new battery every match, is making sure you have the confidence in that battery to actually do what it's intended to do. Instead of putting a battery in that's 5 years old and it's always worked so far there, or just putting it back into your stream instead of knowing that okay, that particular battery, that's the bad one, it needs to get out of here.
Yeah, so it's also important to have some kind of a logging system for your batteries, just so you can make notes of like so this battery was bad, or this battery is still good, or we battery baked this last on October 16th or whatever it was. We actually will have a kid in the pit who is specifically responsible for the batteries. Typically speaking, it's our pit electrical member, but we keep 12 batteries in the pit, and he makes sure that we go one at a time, and each battery gets one use before we start cycling over anything for a second time.
One thing I saw, I'm not sure what team mentioned it, but battery beaking before and after a match. If you don't have the ability to do one of the analyzers to figure out how good your battery is, if you start seeing it dropping more voltage than normal, and you can't say, well, we play defense or there's something wrong with the robot, that may be one way to sort of give an idea that maybe don't use that one during eliminations.
Yeah, and also if you log which battery was used in which match, then you can start to identify trends of like, oh, hey, we ground out in quals, 1, 58, and 87, and we used the same battery in all three of those matches.
Mhm. Yeah, so it can be really, really helpful for all those troubleshooting efforts to, if it's popping up on some matches but not others, to be able to figure out what's the consistent thing that's going to be there to point your finger at and have any more confidence that it is actually it's much nicer to know you got the actual problem instead of, well, I think that may have been it. Let's keep trying and hope we actually got it, and instead of knowing, all right, we have proof that this was it. That's the problem. We don't have to worry about it. We might have to worry about new problems, but not that problem. but But yeah, on that standards front, I'd recommend each team try to set their own standards. If you have a wiring connector preference, if you are using connectors, or whatever you're doing, try setting a standard and holding yourselves to it and continuing on improving it. If you should find something that works any better, I think we've talked about it plenty amongst the group here of seeing something new and trying something new, and if it passed the test to get on the robot. But yeah, continuing that effort of trying to improve, but working off of a known standard always helps instead of trying to recreate things year after year.
So if you do
And this-
connectors, like for example, the Molex SL connector, right? We're using those and looking at them. Most connectors will have a strip length and how to strip them and how to, actually do the connection. And on the Molex one, the number I remember easy because it's 2.54 millimeters, common number in FRC, right? So basically from 2.54 to 3.17 millimeters is what your strip length is, right? So it's not just, am I stripping it, is it the right length so it sticks in the right spot? And so check whatever connector you're doing and figure out how to strip it. And if you, there are strippers out there, you can set the lengths. The Molex one, they have their own stripper that goes down to 3 millimeters. So a lot of the $30 ones go down to 5 millimeters, and you have to sort of like eyeball it, and you definitely want to be careful with doing stuff like that.
The genuine Wago lever nuts also have the strip length printed on the sides. You can hold the wire up to it to see if it's stripped to the correct distance. Also
Yeah,
important to buy the genuine Wagos. There's a lot of knockoffs out there, and the Wago brand Wagos are much better.
That, and I like the ones that are clear that you can actually see. Like, okay, I know that has good contact, instead of having the wire strands all bunched up and not having a good clamp on it. We are a little over our hour ballpark, but if anybody has any last questions, comments, thoughts as we work towards wrapping up here.
So just to shill my own team stuff, we have a fall workshop series that's all published on our website, and we have a couple of good electrical workshops from 2022 that are worth watching. Some good content in there.
Yeah, I watched a lot of your content. It's really good stuff. I'll wrap mine up with a couple things that have taken us out in a match. Things that take us out in the shop don't count, right? Because you found it. But power to the radio, right? That's been a historic issue. We finally figured out a way to make sure our radio was powered. Actually, the strain relief for that one was attached to something, and that something came off. So the wire was mounted and screwed down, but basically the wire ended up failing the tug test as well. But I believe that this new Vivid hosting radio is going to solve a lot of that problem quite a bit. And I've had some networking issues with network switches taking me out. And again, that Vivid hosting thing I believe will get rid of a lot of those failure points. The only other thing that took me out was last year was, I know we were chasing CAN issues all year. And basically we went from a tank drive team with pneumatics to a Swerve team, all electric. So we had a bunch of motors. We were mixing Rev with CTRE. We didn't know what was going on with software, hardware. We just stripped the entire robot down, rewired the entire CAN bus, had a CTRE CAN bus and a Rev CAN bus. And just said, y'all don't play well together. And we took them apart, and we never had a CAN issue again. Now that I'm not saying that's what fixed it, because we literally just rewired the whole thing and just started over. we never quite figured out what was going on. That was a
Yeah.
frustrating year.
Yeah, I would say, my motto this year is basically decide what you're going to do, practice what you're going to do, and get that worked out and have the process. So that way, when you do it in season, you're good to go, right? So practice the inspections of where we're working out in the off season, and go through that process. This past year, it turns out we weren't really well, we had at Grits, we had wiring problems, but at DCMP, we had a similar issue. We didn't realize one of our turn motors was drawing 90 amps. And we found that out quals 11 at DCMP, and we're like, well, maybe that may be why a lot of our problems with the odds on and everything else was having problems, right? So there is a bunch of logging now. So if you want to pull that stuff, there's a lot of great information. There's a lot of great log tools that are out there if you pull the information. If you're not sure what to do, or if you want to ask help, I will throw somebody under the bus. I'll direct you to Josh Riddick on our team, who's leading that effort to be able to understand what data is on your robot, so you could understand where problems are at.
Mm-hmm. Yeah, I'd make any similar comments to, as Brian mentioned earlier, of practice off season, and then execute during the season. So a lot of that comes with, again, developing standards for your team in which you're operating by, and executing those standards come season. But again, a lot of it's seeing what is out there already for standards. Always looking at different teams, going around in pit set competitions, talking to mentors or students from other teams to learn what they did and see what you like. But always keep that idea out there that there might be a better solution than you currently have. To keep your mind open to trying new things out. But yeah, Thomas, you muted.
For wires,
Muted.
hot glue. Let's see. Nordlocks. Fewer connectors. That's about it.
Zero connectors.
So I will cede my final thought. We've had a couple questions come in from our audience. One of which is, how does Citrus run low power devices? Some teams splice their low power devices together and plug straight into a PDH, into a VRM, NPM, or another external voltage regulator. From what I've seen, would be one.
So, if I remember correctly, we have 2 VRMs on this robot running all the assorted low power devices. So I think we have one of them on the switchable port, and then one of them on one of the auxiliary ports on the PDH. I don't think we have any that are like spliced to run together or anything. But I'm going to admit I'm not 100% on an answer. Sorry.
Awesome. Thank you.
Anything else, Thomas?
Then the one last one is also, how does Citrus use data logging like Advantage Scope kit to diagnose issues in between matches?
Advantage Scope is the absolute gold standard of everything in FRC. You should absolutely use it if you have the resources to figure it out. The easiest things to check are always just like, are any motors drawing more current than they're supposed to be? That's always like the first level check is are the current poles correct? Beyond that, there's a bunch of fancy simulation work that I am very much a hammers and wrenches guy, and I don't have a lot of visibility into it. I wish I had better answers. But I know that Advantage Scope, the software kids are very excited about Advantage Scope. The software coaches are very excited about Advantage Scope. I'm excited that they're excited, but I can't give any specifics there.
Awesome. Thank you. I think that's where we'll
end it.
We'll end it.
Yes, exactly.
Oh, one more. Does Citrus have connectors on their intake? I know they say they take it off and on a lot for repairs.
We just have a Kraken on the intake, which means we just have the ring terminals, which are really, really easy to swap out. So one thing on those is that you need to get the torques right.
Yeah.
There's God, I don't remember off the top of my head. Kellen, do you know what the torques are supposed to be?
I forget what the rating is, but I know doesn't West Coast Products sell a torque wrench that's an option?
Yeah. There's a torque wrench for the Kraken. Use it. Don't just go by feel. It's really critical to success there.
Yeah, that and it's an expensive mistake. should you either over torque it or yeah.
It worked.
Yep.
It's an expensive mistake either way. If you over torque, you might break the motor. If you under torque, you might die in a match.
Yeah. Yep.
They're both about the same price.
Good point. But I guess
and they did say in the chat that it's between 0.9 and 0.6 in M. I don't know if that's what
Newton
in M
meters.
is.
Newton meters.
Newton meters. But and then this is going to be the official last question, just because every time we ask a question, they add like 3 more. How fast can an intake? How fast were you all able to intake and swap out an intake at the Pickett season?
I would say we were at our peak, probably we could do an intake swap in maybe 5 minutes. The hardest part of this intake, that's getting all the mechanical stuff. The hardest part of this intake, that there's 3 pieces of surgical tubing that you have to wrap around it, and getting them to secure in place is actually a huge nightmare, and that probably takes longer than the rest of the intake process. It's the sketchiest thing I've ever seen on a citrus robot, this intake.
Yeah. That's one of my
the
usual comments.
The answer you're looking for is about 5 minutes. It's probably more like 15 if you have to redo the surgical tubing.
It's one of my usual comments for teams like designing how they're putting their battery in and out of the robot. I'm like, this is one of the things you're going to have to do the most throughout the year. Make it as easy as you possibly can instead of making
so bad
your
at
life.
that.
Yeah. Nope, we made it difficult. We're going to have to deal with it.
The 2023 robot, it's directly under the pivot. Like, we have this big pivoting elevator, and you have to like wrench the whole thing up and like go all the way through the robot to get to the battery. It sucks.
Yes. That and putting bumpers on and off. That's my other sticking point. Like, make that as easy as you can.
Yeah. One thing I forgot to mention, there's some parts of your robot that are easier to inspect when the bumpers are off. So every time you have to do a bumper change, when you get the bumpers off, do a thorough inspection of the whole frame perimeter.
Mm-hmm. Good point.
Awesome. Thank you. And I think with that, I know most of our students are coming up on their last week of the semester, so we should probably end it now so they can rest up for their midterms.
All right. Yeah. Thanks for joining us for this.
Yeah.
Yeah.
Matt, thanks you so much for joining us. We're kind of.
Thanks for having me.
We'll keep talking, but we need to.
Yeah, sure.
Yeah. Best of luck.
Giving us the hook.
Best of luck to all the teams present on this call, but all those listening, all those who might see this in the future. Best of luck with kickoff coming up in a few weeks. Enjoy the rest of your break while you can. But yeah, hopefully they've covered some useful content here and there. But yeah, again, thanks for joining us. We'll see you in a few weeks for our kickoff episode of Peach Pit and any of our episodes for the upcoming season. But thanks for joining us.